All right, two Peters, here we go. Day 2 of the sine and cosine ratios. Expectation 2 point, actually that's 2.3 it should be. I don't know what it says on yours, but it should be 2.3. Find unknown sides and angles using trigonometry. That's what we've been doing, and that's what we're doing today. Example 1, in triangle ABC, blah, 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 a whole bunch of stuff. Find all other sides and angles. Well, what makes this one tougher than the 3-minute review questions is we don't have a diagram. Can't see what's going on. Is it sine? Is it cosine? What are we doing? Well, let's draw a diagram, right? So that's the first step. Draw a diagram. And remember, if you're having trouble keeping up, this note is actually on the smartboard as we speak, and then you'll have a chance to copy it later. I hope that you could keep up because I'm not that fast really. ABC. So let's draw ABC. You should be doing this with a ruler. Draw nice, neat notes with a ruler. Right. Here we go. Well, it's pretty close. Right, and then there's my 90-degree angles here. And so I can't just put ABC anywhere. I got to be careful that I know which one is the 90-degree angle. And there it says right there. So this has to be A here. Then B and C, do I care? Nah, not really. But that'll tell me where these other things are. So C is 35 degrees. And I'm going to start writing. What's going on here? Something's flashing at me. Ignore it. C is 35. So that's 35 goes in there. And little b is 12 centimeters. Well, remember, that's the side across from it. That's 12. And then it says, find all other sides and angles. Now, by the way, this is called solving a triangle. When you're asked to solve a triangle, this means finding all other sides and angles. So what are the things that we need to find? Well, what I like to do is I like to list everything. Side A, side B, side C, angle B, angle C, list everything, and then we'll know when this is full. And I'm just going to write the givens in here. This one was 35. A was 90. And little b was 12. And so when this is full, we know we're done. Well, notice one of them is really easy. This is a grade 9 problem here. Is angle B is just 180 subtract 35 plus 90, right? Angle B is equal to 180, subtract 35, subtract 90, clunk that into a calculator. Where's my calculator? It shut off on me. 180, subtract. Can you do this in your head? Maybe you can do this in your head. A good way to think of this in your head is, you know that 90 is what's left after you take away the right angle, and then you just need the two numbers to add up to whatever's left. 90 and 35 and 55 do. So this is 55. And then I'm going to write that in over here as there's one of my answers. 55 degrees. So this is 55 degrees here. Dandy. And then now find out one of these other ones. Well, which one? Doesn't matter. Doesn't matter. Let's try and find A first. What the heck? A first. And then say, well, which angle do I use? Well, it doesn't matter. Let's say we're going to use the 35-degree angle. And then what sides do I have for SOHCAHTOA? SOHCAHTOA. Well, from the 35-degree angle, A is the hypotenuse, right? That's the hypotenuse. And which one is 12? 12 is the adjacent side because it means next to. We identify the hypotenuse first and then the adjacent side. So adjacent and hypotenuse, I'm going to write down the cosine. The cosine of 35 degrees is equal to the adjacent 12 over the hypotenuse little a. And remember, when A is on the bottom, it's an extra step. It's a little bit of a hassle when it's the hypotenuse I want to find, but most of you are getting used to these two just switch places. And I end up dividing. And so that gets clunked into a calculator. 12 divided by the cosine of 35 degrees. And it should be a longer side than 12. For 13.4. And that's what is this? This is in centimeters. So A is 13.4 centimeters. And then C, how are we going to find C? Well, it doesn't really matter, right? Now that we've got two sides in this right angle triangle, we could use Pythagorean theorem. We could use, you know, A squared equals B squared plus C squared, where this is 13.4 and this is 12, and we want to find C, and I could finish that off if I want to, but it's trigonometry that we're doing here, so I'm going to do a trig one, where I want to find this little c. From little c, from this angle 35, what's the c then? Well, it's the opposite side, and the 12 is the adjacent side again. Opposite and adjacent, what is that? Opposite and adjacent. Opposite and adjacent is the tangent. So I go, the tan of 35 is equal to c over 12. Cross multiply. 12 times the tan of 35. Clunk that into a calculator. What is it again? 12 times tan of 35 equals 7.7, about 7.7. And now my thing is all full, so I know I'm done. I think we got one more example, and this is kind of like a problem. Ferd is building a roofing section for a doghouse. He has 4-foot boards for the horizontal beams, the span, and the roof will have a pitch of 30 degrees. How long are the rafter beams? So we've got a diagram here, and it's pretty complicated diagram, I suppose. But what is it saying here? Let's write some of this given on here. He has 4-foot boards. So this is the span here. The span, this is 4 feet. There. Well, notice in this triangle, we don't need all the way across. There's my right angle triangle right there, right? I'm guessing that's a 90 degrees. So what's this side here? Well, that's 2 feet, isn't it? That's 2 feet. Or if I wanted to change that to inches, how many inches is that? Right? 2 feet is equal to 1 foot is 12 inches. So 2 feet is 24 inches. I just multiply this by 2. So this is 24 inches. And then what are we asked to find? Well, what else have we got here? And the roof will have a pitch of 30 degrees. This is 30 degrees in there. And so there's my angle. And what do I want to find? How long are the rafter beams? The rafter beams is this part here, L. So from this angle that's given, what are the sides? So I've got the hypotenuse, right? This is the hypotenuse. This is the adjacent side. So SOHCAHTOA. Adjacent and hypotenuse, that's the cosine. So I'm going to write down the cosine of 30 degrees is adjacent, and I'm going to use inches, 24 inches over the hypotenuse, which is L, and which is what I want to find. Cross multiply. Same steps now, eh? It's getting boring. All these same steps, doing the same thing over and over again. It's good practice, I guess. And then I put that into a calculator. 24 divided by the cosine of 30 degrees. Press enter, and that's 27.7, and that's in inches. 27.7 inches, and I know we're kind of worried about the 0.7 inches, but don't be too worried about it. Now notice that that's this. It also said that this is a 6-inch overhang. That's a 6-inch overhang. So the rafters should be 27.7 plus 6 is equal to 33.7 inches long. And again, if you're in Mr. Faber's class, he'd want you to change that to a decimal, and 0.7 is about 3/4 of an inch, and you can check them. 3/4 is 0.75, right? So that's not so bad. Done. There's the homework, and notice that any 4 of all of those, so you pick them, they're word problems probably, and then if you're real nice, maybe the supply teacher, the on-call teacher, will play the Get Triggy With It video for you again. You just click on that and you can see that video. Get you in the mood for the home.